Hello everybody, today we're going to be looking at the unit circle. It's kind of an interim section between what we were doing and what we need to be able to do 8.3 more effectively. So on Canvas there is a sheet or two sheets that you need to print out. It has two circles. One has a circle and it has a more narrow triangle on it. And then for the other one it also has a circle and it has a more square triangle on it. You do want to print these on two separate sheets. I'll explain kind of why later, just trust me for right now. So if you need to go do that, pause the video and go do that. If you have it, great. We can go and get started. So today I'm going to be using about 4 or 5 different colors. So I would grab some different colors. We're going to try to save those reds and blues for later because we're going to be going back to that opposite and adjacent later. This is probably going to be a little bit longer of a video. I'm going to try to condense it down as much as I can, but just be prepared for that. For today, again, grab those color pencils, markers, pens, whatever. So our first step on these triangles, and you want to make sure you're writing legibly, nicely, and reasonably small because these circles are going to get cluttered somewhat quickly. So starting out, we talked last time about taking a circle and doing degrees and radians. So for degrees, they started at 0, and make sure you're putting, I would recommend putting everything exactly where I put it. Okay, it's going to save you a lot of hassle later. So we started out, we had 0 degrees, and then we went all the way around the circle and we said we were at 360 degrees. Okay, which meant 90 degrees was up, or sorry, 180 degrees was over here because we cut it in half, and then 90 degrees was up here because we cut that in half. And then we could count by 90s, and we end up with 270 degrees down here. Okay, please take a second. Again, there's going to be several times you're probably going to want to pause the video here and put the cross here and then those angle measures on both circles. Okay, you're going to need it on both circles. Okay, once you have that done, we're going to swap to a new color. Let's go orange. And then we're going to do those radians. So radians went from 0, we went all the way around, we ended up at 2 pi. Cutting that in half, we were at pi. Cutting that in half, we were at pi over 2. And then counting by pi over 2, so 0, pi over 2, pi, or sorry, 2 pi over 2, which is pi. We end up at 3 pi over 2. Okay, so those are our angles and radian measures for our standard, just like 90-degree angles, and that's going to be on both of these circles. So again, make sure you're getting these on both of those circles. So those are our interior angles for just kind of the default circle here. Okay, now I don't have to stop there. I had 0, 90, 180, 270. Okay, well I could cut this in half again, right? If I'm cutting it 1 in half, I should probably cut all 4 in half. Okay, well if this is 90, half of 90 is 45, and again we're going to count those around. So we're going to add those pieces. Okay, so we had 0, we're going to have 45 degrees. This is going to go on your sheet with the more square triangle. So for me it's the second sheet, maybe a first sheet for you, but it's the one that's more square, not narrow. Okay, again we want to keep these separate. So 45, 90, 135, 180, 225, this over there, sorry, 270, and 315. Okay, or sorry, and then 360. Okay, and then we took radians. Okay, we said this was pi because we cut 2 pi in half. Cut it in half again, we got pi over 2. So if I cut it in half one more time, put that on the other side. And it doesn't matter which side you have them on, just it matches up with that line. But if I cut a half in half, I get a fourth. So then this is pi over 4. And then if I count by pi over 4s, right? Pi over 4, 2 pi over 4, which is pi halves, 3 pi over 4, 4 pi over 4, which is pi, 5 pi over 4, 6 pi over 4, which did reduce down to 3 pi over 2 for us, and then 7 pi over 4, and then 8 pi over 4, which does reduce down to 2 pi for us. Okay, so those are those angle measures, both radians and degrees. Okay, so anytime I ask you, if I say, okay, well, what is the radian measure of 45 degrees? Well, it's right there. If I ask you, what is the degree measure of 5 pi over 4 radians? Right over here. Okay, so we can always come back to these circles as references. Now, 45 is one of the common angle types. Okay, and when I'm doing these, we're going to look at a circle in a second where we also have a 30-degree angle type. The 45 and 30 are the two big ones, and we'll see why in a second, but it comes down to those special right triangles, the 45, 45, 90, and the 30, 60, 90. Okay, so doing the same thing. We start at 0, we're ending at 360, cutting that in half. Okay, but wait a second, if I cut this in half and cut this in half, I'm cutting this into thirds. There's another way we can look at this. We can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 equal sections. So 360 divided by 12 is going to be 30 degrees. So each of these is 30 degrees, so I can just count by 30. 30, 60, degrees, 90, 120, 150. Okay, again, it doesn't matter which side of the line you're on, but I would be inside the circle because we're going to need a lot of room outside the circle later. 180, 210, 240, 270, 300, 330, 30, and then 360. Okay, well, let's use that same idea, same principle with radians. So remember, we start at 0, we end at 2 pi. So 2 pi over 12, that's going to simplify down to pi over 6. So we're going to count by pi over 6s. So 1 pi over 6, 2 pi over 6. I'll come back and reduce in a second. I'm just counting right now. 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6, 7 pi over 6, 8 pi over 6, 9 pi over 6, 10 pi over 6, 11 pi over 6. Okay, sorry, I also forgot to mention this is going on the one with the narrow triangles. I'm going to try to remember to put a note on the YouTube video, but these should go on the narrow triangles. So, and then 12 pi over 6. Okay, so 12 pi over 6 matches up with 2 pi, yay. Okay, this is going to reduce down to pi over 3. This will reduce down to pi over 2, which is nice because that's what it matched up with on our other one, pi over 2. This is going to reduce down to 2 pi over 3. Won't reduce. This will reduce down to pi. Again, that works out nicely for us. This will reduce down to 4 pi over 3. 3 pi over 2, again, works out nicely for us. And 5 pi over 3. Okay? So again, those give us those internal angle measurements, and that's going from 0 all the way around the circle. So that's both the pi's, or sorry, the radians and the degrees. Again, this is really nice for us because if all I'm trying to do is convert and it's one of these nice ones, the 30s or the 45s, all I need to do is say, okay, what's the radian measure of 90 degrees? I come here, it's right there for me. Okay, and I can go back and forth really quick. Okay, so the next thing we need to look at is the points on this circle. Okay, so I mentioned earlier that we call this the unit circle, meaning the radius is 1. Okay, so if the radius of this circle is 1, then from the center to any point on the circle should be 1 unit. Okay, now that 1 unit can be 1 cats, 1 yards, 1 feet, 1 dog, doesn't matter, it's 1. Okay, and it's going to be important for what we're about to do that it is 1. So now I need to think about this. Okay, if I put this on a coordinate plane, so I extend this out. Right? Then if I start at 0 and I move to the right, I'm going to be at the point 1, 0. Okay, now I'm using some colors here that are going to make a little bit more sense in a little bit. So just use the same colors I'm using for right now. So I'm going to have 1, 0. Okay, again, these colors will make more sense in a little bit. Just trust me for right now. Same thing. If I go up 1, I'm going to be at 0, 1. Okay, if I go left 1, and this is on these points on these corners, or not the corners, but the edge. I'm going to put this one down here, save myself some time. I'm going to be at negative 1, 0, and then 0, negative 1. Okay, and that's just because I'm moving exactly 1 in one direction. So the question comes into play, if I pick a random point on the circle, let's say right here, halfway between, right? So, near to where that 45-degree angle is. What is this point and how do I find it? Let me use triangles. If I took a line and dropped it straight down, then I have a triangle. Okay? And to get any point on a coordinate plane, I need to figure out an x value, my movement to the right or left, and a y value, my movement up or down. So if I want to find whatever this value is up here, this. If I want to find whatever this value is up here, I need to figure out how far right I went and how far up I went. Just like for these, right? I went right 1, and then I didn't go up or down, so 0. For this one, I went up 1, or up 1. I didn't go right or left, okay? Left, negative 1. Up or down, 0. No left or right, down, negative 1. So that's where those came from. Okay, and again, this idea that I'm going to go right and then up to get that point, because that's how you get any point. Well, again, this makes a nice triangle for me. I have an angle that I know. I have one side that I know. So I should be able to use sine, cosine, and tangent to find the other sides. So let's go do that. We're going to start off with that more square triangle. So we're on that second sheet for me, if you got it from me, with the 45, 45, 90 triangle. So I got 45 degrees, 90, 45 degrees. Okay, now so there's no confusion, let's use this bottom right, 45 degrees. So if I mark up my triangle, and you want to do this in that bottom corner triangle, this is going to be my opposite. This is going to be my hypotenuse. And then this is going to be my adjacent. Okay, well, we know our hypotenuse is 1. Yay, that's one side down. Okay, so if I wanted to solve this for the opposite, right, because I can't do the opposite and adjacent at the same time because that'd be 2 variables. And I'm picking some very important letters here for my variables. You'll see why in a second. Okay, but let's start by finding opposite. So the sine of theta, remember, is equal to opposite over hypotenuse. So the sine of 45 is equal to y over 1. I'll multiply that by 1. Okay, go over to my calculator. I do want to make sure I'm in degrees. I'm not. So I want to get in degrees. And then I'm going to say sine of 45. Well, that's frustrating. It wasn't a nice number for me. So y is approximately 0.707. There's got to be a better way to do this so I can get an exact answer. It'd be really nice if I knew exactly where that point was. It's close to 0.707, but it's not quite there. So let's think back to what a 45, 45, 90 triangle means. Okay, so let's get rid of this sine stuff right now. A 45, 45, 90 triangle is a right triangle, but it is also isosceles. Isosceles triangles have 2 sides that are exactly the same. So in this case, x and y are the same. Okay, now they're not the same as h because it's not equilateral, but because it's isosceles, x and y are the same. So let's pick a new variable. Let's pick variable z for a second. So if I think about the Pythagorean theorem, right, x and y are the same, so I'm just going to say they're z for right now. So z squared plus z squared, and really like x and y, right, but they're the same, so I can just put in a z, is equal to 1 squared. Well, z squared plus z squared is 2z squared. 1 squared is just 1. So let's divide by 2. Z squared equals 1/2. Get rid of this square. So z is equal to the square root of 1/2. Okay, well, let's check it right now before we do anything else. Let's see if that tracks. So square root of 1/2. Okay, that's a good sign. But again, this isn't a great answer because really this is the same thing as the square root of 1 over the square root of 2. Can't have a square root in my denominator. Square root of 1 is really nice though, right? Okay, and then rationalizing, we would just do square root of 2 over square root of 2. So we're going to have 1 square root of 2 over 2. Okay, now I don't really need that 1, so we can just say square root of 2 over 2. Okay, again, just double checking. Square root of 2 divided by 2. Okay, good. Same answer. So my distance here is square root of 2 over 2. And then my distance here is also square root of 2 over 2. Okay, and again, depending on how accurate we're wanting to be, that decimal might have worked out for us. Okay, but again, I want to make sure that you're ready for calculus, and you are going to need this for calculus. Okay, so here's my triangle. I've got a side that's 1, a side that's square root of 2 over 2, square root of 2 over 2. So let's take that triangle. We're going to put that triangle, and again, we're on that second sheet with the more square triangle. Put a dotted line going here. Okay, now we said, and these colors will make sense in a second, we said that going from here to here was the square root of 2 over 2. On this side of the triangle, going all the way to here and stopping, not going all the way. And then going from here all the way up to here was also square root of 2 over 2. So then this point up here, I went right square root of 2 over 2. I went up square root of 2 over 2. So square root of 2 over 2 for the right. And then up also square root of 2 over 2. Again, make sure you're using these colors. I'll explain why very shortly. Okay, so why am I using these colors? Well, if I go back, or sorry, if I think about this, okay, my opposite was over here. My adjacent was over here, right? So my opposite's up here, my adjacent's down here. So adjacent seems to be coming from this x value. Okay, it's going to be a little easier to see on the 30, 60, 90 triangle because we're not going to have the same numbers, but it's really coming from this x value. Whereas my sine, the opposite over my hypotenuse, comes from this right number. Okay, so that's why I made these color choices. Okay, last thing we need to do for this circle. So far we have all the angles on the inside. I'm not going to rewrite those because those aren't important right this second. Okay, so I want to put points for each of these. Now, it'd be really obnoxious to have to do that triangle a bunch of times, okay? And we already have some of these, right? We know that this is 1, 0, 0, -1, 0, comma, 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 0, 1, 0, -1, okay? And we said that this was the square root of 2 over 2. And this was also the square root of 2 over 2. And we got that again from making that triangle. Well, I can make a triangle on any of these, right? For this point over here, I'm making a similar triangle. We always want to start at the origin and again go out, right? And then up, okay? So for down here, again, going left and then down, going right and then down. So these angles here are what we call reference angles. A reference angle is the angle you would use on the triangle that you would create. Okay. For this one, yeah, 45 degrees. Again, I wouldn't write these reference angles on here. And if I was talking about this line, right, we said this angle earlier was 45, 90, 135 degrees. But the reference angle that it makes with the x-axis is 45 degrees, just like here. Just like here. And again, I wouldn't put these 45s. Do draw the lines here, though. So with those 45s, we have the same triangle. It's just flipped. I took this triangle to get this one down here. I just took it and I flipped it down here. To get the one on the left, I took it, I flipped it over here. Okay, now to get the last one, I need to flip twice. I flip it over here and then I flip it down. But it's the same triangle, which means the sides should all be the same. This side is square root of 2 over 2 up here. It's also square root of 2 over 2 down here. Over here, square root of 2 over 2, square root of 2 over 2. Now I do need to be careful though. In this, on the right side, I'm going in the positive direction. On the left side, I'm going in the negative. So really, it's negative square root of 2 over 2. Same idea. This is square root of 2 over 2. So then this should be square root of 2 over 2. This is square root of 2 over 2. So this should also be square root of 2 over 2. Okay, but again, positive and negative, right? Positive is up, negative is down. Okay, so if I think about this, and I think about the quadrants, right? Because this is like the first quadrant over here on the right, second quadrant, third quadrant, fourth quadrant. I have rules for those. This would be negative square root of 2 over 2. Because I'm going left, but I'm also going up. So positive square root of 2 over 2. Left and down is going to be both negative. So a little bit more room here. Again, going right is going to be positive. Going down is going to be negative. Okay, and there we have it. We have it finished almost. I want you to add one more thing to this. In blue, I want you to write the cosine of an angle is equal to x. The sine of an angle is equal to y. Cosine of an angle x, sine of an angle y. So what I mean by that is if I say, what is the sine of 45 degrees? I look at 45 degrees, I go out to my point, I look at my y value, there it is. If I say, what is the cosine of 90 degrees? Go to 90 degrees, go out. Cosine is blue or x, so it's 0. Okay, and just to check that, cosine of 90 is in fact 0. Okay, if I wanted to do the sine of 225 degrees, 225 is down here. Yeah, remember this is just the reference angle. You should have the purple one down here. It says 225. If I say sine of 225, negative square root of 2 over 2. If I said 3 pi over 2, remember 3 pi over 2 is down here, and I'd say cosine of that. Cosine is blue, so 0. Okay, I'm going to go ahead and end the first part of this video here, so you guys can take a break. Make sure you do watch the second part of the video. We will finish the other circle. A lot of these concepts should flow pretty quickly though, because we've already kind of covered why things work. Okay, so again, I'm gonna stop this one here. Once you are good and ready to move on, make sure you do that second circle.